All right, everybody. Hopefully, I have at least a few people watching this. I know it's tech week, and I'm sure rehearsals are running late, and we just had one of these yesterday, but hopefully, at least a couple people are watching. We are going to do ourselves a review on quadratics. That's actually going to include some absolute value stuff in there, too. Okay. Um, we're going to take a look at this stuff tonight. Sorry, I wasn't super responsive to the chat yesterday. I actually couldn't, with my setup at home, figure out how to see the chat window. Looks like I see things a little bit better tonight in terms of the chat window. So if there are questions, feel free to type them in there. If not, that's no big deal. I'm happy to just kind of go through these things and see what we got there. Okay. We'll go through some of this stuff and we'll see how it goes. Okay. Yeah. So without further ado, this first set of questions, all the way through the first four, you're being asked to simply not use the quadratic formula. Okay. Um, Really, that doesn't come into play at all for the first two, but it definitely will come into play for the second two questions, or could, but we got to avoid it. We got to make sure we know how to deal with that without using the quadratic formula. Okay. So first things first, the absolute value problem. Hang on, before I go any further, my bad. One big thing, all of these are pretty much going to have two answers for the most part. Okay, that was kind of our theme for the unit. While it ended up being quadratics for the most part that had it, so things with a squared in there. The absolute value problem too will have two answers. Okay, so that's what you want to be looking for: is how do I get my two answers? What that means, unless we're using the quadratic formula, is at some point we're going to transition from one equation to two equations. Okay, and we want to make sure we understand where that transition is, especially in terms of a final exam. That's kind of a big thing, right? Like if for all of these questions that are supposed to be getting two answers, you're only supposed to get one. That's not great. So we just want to make sure we know, what does a question look like that has two answers, and how do I get to those two equations that are going to get me there? So for the absolute value one, it's really pretty straightforward. Because an absolute value can turn a negative number into a positive number, the two equations we're going to solve are 3 minus 6x equals 57, and 3 minus 6x equals negative 57. All we're really going to do now is solve for x, just like we've been doing since 7th grade for most of us. Okay, we're going to subtract 3 from both sides, and we're going to divide by negative 6. So for my first solution, I get x equals negative 9. And for my second one, shout out to Mason, who has showed up here just to, say hey. Subtract 3 from both sides, and divide by negative 6. And my second answer, I get x equals 10. You could plug both of those answers back in and check if you really wanted to, but in the end, that's how we get our two answers there. Okay, moving on. Number 2. The first thing we're going to do here, we have a squared all by itself, and we're going to take the square root of both sides. Okay, and here's where we're going to create our two different equations. Okay, the first equation that we're going to create is 2x plus 7 equals 5. Here's where we're going to create the second equation. The second equation we're going to create is 2x plus 7 equals negative 5. Okay, and the reason that we're going to do that, sorry about that. The reason we're going to do that is because if you square 5 and if you square negative 5, both of those would get you 25. So really, when we're taking the square root there, we're going to now solve both of those equations. Okay, solve for x, subtract 7, 2x equals negative 2, divide by 2, x equals negative 1. Okay. All right. Then next, subtract 7, 2x equals negative 12. Divide by 2. X equals negative 6. Okay. That's it, folks. Take the square root, set up your two equations. Okay. What we're going to find is in the next two, what we're basically going to do is we're going to be trying to set up a problem that looks exactly like number two. Okay. All right. That's what we're going to try to do. Ready? Here we go. So uh, for number three, and this is kind of the reason. Oh, Sophia actually asked a good question that I'm going to do right before I start this problem. Sophia asked, I got the same answer, but by factoring, is that okay? So, I mean, in reality, yes, that is absolutely okay. Anytime you get the same answer, if it was by a slightly different method, you're okay. In this particular section, as long as you don't use quadratic formula, right? It says do not use quadratic formula. As long as you didn't use quadratic formula, you're totally fine. Okay. For number three, we're going to start off with factoring. Okay. We're going to factor this into x plus 3 times x plus 3. Okay, that's straight out. That's a door problem straight out of our review from yesterday. Okay, now we're going to rewrite this though as x plus 3 squared. Okay, and the reason we're able to do that is because we got two of the exact same parentheses there. Okay, now what we've basically done is we've created a problem just like the one we had above. Okay, so we're going to square root both sides. I'm going to change colors because I feel like it. And this is where we're going to set up our two equations. Okay, we're going to set up x plus 3 equals 6. Excuse me. And x plus 3 equals negative 6. We're going to solve both of those for x. I get x equals 3 by subtracting 3 from both sides. Probably should have wrote that. And I get x equals negative 9. So very similar problem to the last one. It just starts with factoring. Okay. Now, for our next one, I'm going to actually show you two different possibilities for how you could handle this one. Okay. And I'm going to show you two different possibilities because I think they both kind of make sense for different reasons. So, one issue that you might notice is that if you look back over at this problem, the reason that one worked out so well is because it factored into x plus 3 and x plus 3. It factored into two of the same thing, so I was able to write it then in that next step with a little x squared. Okay, I can't do that in this one because this will not factor into two of the same number. Okay, this equation will not. Okay, so what I'm going to do is I'm going to do a process called completing the square. Okay, and we spent a good amount of time on this. But what we want to make sure we do is we want to get it to factor into two of the same thing. Okay, this is actually not too terrible of a thing to do. Basically, what we're going to do is we're going to jump ahead a few steps and we're going to say, okay, I would prefer this be n squared plus 16n plus something different. Okay, I don't want that negative 36 in there. Okay, and the way you figure out what you want that third number to be, we had a little shortcut for it. Okay, we're going to take our 16, cut it in half. That's 8. And then we're going to square it. That's 64. So what we actually want that last number to be is to be 64. Okay, so this is what I'd like to end up with. Okay, now what we have to do is we got to look back and we got to say, hey, well, how do I get from negative 36 over to 64? Okay, and the way that I do that is I'm going to add 36. Okay, the reason I'm adding 36 is because all I'm going to do is make that negative 36 into a 0. And now if I want to make it 64, I add 64. But I have to do that to both sides. Okay, so I'm doing that to the negative 36 and I'm doing it to the 0. Okay, doing it to the negative 36 just makes it into 64. Doing it to 0 means I do 0 plus 36 plus 64 and I get 100. Okay. That little bit of math sets you up so now you can do the exact same thing you did on the last problem. You can factor it like a door problem, n plus 8 times n plus 8. Okay, and then I can change that to n plus 8 squared. And then I can square root both sides. So really, it was a quick setup step to get myself to the exact same point that I was in the previous problem. Okay. N plus 8 equals 10. N plus 8 equals negative 10. Okay. Subtract 8 from both sides in both of those. And I get n equals 2 and n equals negative 18. Now, that was, again, that method was called completing the square. So this process of turning that last number into a 64, so it factored into n plus 8 and n plus 8, that's called completing the square. You didn't have to do that problem that way. You could have also tried to do quadratic formula, which wasn't allowed in this section, so that isn't going to work for this one, but on a problem like that, you could. Or the other thing that you could do is you could solve it with factoring. Okay. And while we're going to do one of those down below, I did want to take the opportunity to show you that right up here. Okay. So if you wanted to solve a factoring, honestly, that's pretty easy. In order to solve with factoring, your equation has to be equal to 0. Our equation already is equal to 0, so that's kind of awesome. Okay. Once it's equal to 0, all you have to do is factor. I get, it's a door problem. So I'm looking for numbers that multiply to negative 36 and add to 16. Multiply to negative 36, add to 16. Those are 18 and 2. Okay, and then the way you solve is you use the fact that both of those are being multiplied together to get 0. What that tells me by logic is that one of them has to be 0. So I basically set up two little mini equations. N plus 18 equals 0, n minus 2 equals 0. Really, all that ends up doing is just getting you the opposite of those numbers. I get negative 18, and I get 2. The same answer that I got the other way. Okay. Most of the time, I try to do factoring first, but completing the square, the one that I showed you the first time, can be a good option as well. Excuse me. Okay, now we're going to get into one with quadratic formula and then one more with factoring to kind of close up here. Folks, you have to be able to use quadratic formula on your exam. It's one of those things that comes up potentially a couple different places, okay? And in anytime you want to solve something with an x squared and you don't really remember how to do it, as long as you're allowed to use quadratic formula, which I do let you do throughout 99% of the test, maybe one problem I'll tell you not to. But for the most part, you're going to be allowed to use it. So it's a good formula to have at hand when you're solving something with an x squared in it. Okay. Couple things. One, the formula itself, negative b plus minus square root of b squared minus 4ac all over 2a. Alrighty. That's one thing we need to know. The other thing that's super important for us to know is that to use the quadratic formula, you've got to have an equation that's equal to 0. Okay, if you don't have an equation that's equal to 0, you're not able to label your A, B, and C, and things just don't work. So for this particular one, I'm equal to 8. Okay, so I need to subtract 8 from both sides in order to get this equal to 0 just to start the problem. Okay, so 6x squared plus 2x. I'm subtracting 8 from both sides, so I get minus 8 equals 0. Well, what I've written right down here now, and I'm going to circle it. Let's see how that yellow looks. Doesn't look great to me, but maybe it'll show up better for you guys. That is exactly what an equation should look like in order to use the quadratic formula. Okay. If it doesn't look like that, where it goes x squared, x, then the number equals 0, it's got to equal 0. Otherwise, you can't use quadratic formula. Okay. What you do then is you label your a, your b, and your c. Those are just the coefficients. So in this case, 6 and 2 and negative 8. 6, 2, and negative 8. All I'm doing at this point is really plugging them into the formula. Okay, so I've got a negative b in my formula. I'm going to make that a negative 2. I've got a b squared. That's 2 squared. So I'm going to make that a 4 minus 4 times a times c. I'm literally just plugging the numbers in, folks. That's all I'm doing. Everywhere I see a b, I replace it with a 2. Everywhere I see an a, I replace it with a 6. Everywhere I see a c, I replace it with a -8. Okay. At this point, it comes down to how much math you can do on the calculator a little bit. You can do a lot of that at the same time. I typically just do what's under the square roots. That's what I usually do anyway. Okay, so that's actually what I'm doing right now. And I get 196 as my number that's under the root. I'm going to do the 2 times 6 on the bottom too. That's 12. Okay, here's where the plus or minus comes in. This is one of these things that people forget about. Remember, if we scroll all the way back to the top, hopefully I still have that written down. Otherwise, it's going to be a little embarrassing. No, I still have it. Okay, 2 answers. All of these problems should have 2 answers. Okay, all these problems should have 2 answers. So that's where the plus or minus comes in. The plus or minus comes in that you're really just going to do this problem twice. Okay, that's it. So the square root of 196 is 14. Okay, so what I'm going to do is I'm going to split this up into 2 problems. -2 plus 14 over 12 and -2 minus 14 over 12. And I'm just going to get 2 answers from there. This one is 12 over 12, which is 1. And this one is -16 over 12. Up to you to what you do with that, folks. I really just prefer fractions. I would just leave this as -4 over 3. I would divide both the 16 and the 12 by 4 and do that. But you are also welcome to turn that into a decimal. You're probably going to need one of those fancy little repeating bars in that answer. But whatever your answer one, whatever you want your answer to look like, it's kind of up to you. This is the 2 really big things that I want to emphasize again about quadratic formula are it's got to be equal to 0. It's got to be equal to 0. That's number 1. Okay, before you label your A, B, and C, it's got to be equal to 0. Number 2, you get your 2 answers by splitting things up before you do that addition and subtraction stuff. So you take the square root of whatever's up there, and then before you do the addition or subtraction, you do one with the set up one problem with the addition and one problem with the subtraction. Okay. Last but not least, we're supposed to solve another one with factoring here. Let me just erase most of this, get it out of the way. This is, again, a door problem. So I'm finding numbers that multiply to 27 and add the -12. Those are -9 and -3. Because those are being multiplied together to equal 0, I get x minus 9 equals 0 and x minus 3 equals 0. And I'm just solving both of them. X equals 9, x equals 3. Again, most of you will probably just get to right up at this step and you'll just shortcut it. You'll just be like, oh, well, 9 minus 9 is 0, so x is 9, and 3 minus 3 is 0, so x could also be 0. And that's totally okay too. Okay, this is really pretty much it for quadratics. Okay, even if you look at the difficulty level, relatively speaking, like these are the levels of problems up top that you'd be expected to not use the quadratic formula on. Number 5 is one that I wouldn't expect you to do without the quadratic formula, but with the quadratic formula, absolutely, you should be able to handle that. Same thing with number 6 as well. Okay, that one you should be able to solve with factoring or with something else. Okay, but hopefully this was at least a little bit helpful. And if you're watching this later, again, if questions and stuff like this come up as you're using this as a study tool, please let me know. I would be happy to help you with any of those things. Okay, hope this helped. Have a good rest of your night, everybody.